Welcome, this is Professor Ridge. Today's lesson 2.6, Other Types of Equations. And let's get started with the first learning objective, solve equations involving irrational exponents. Rational exponents. A rational exponent indicates a power in the numerator and a root in the denominator. There are multiple ways of writing an expression, a variable, or a number with a rational exponent. So these are all equivalent forms. So the numerator for the rational exponent, we're talking a fraction. So the numerator is the power, right? So you can see the power in this one. And the denominator is the root. So this is the nth root. It's the index. Okay? So looking at example 1, we want to evaluate 8 to the 2/3 power. So if we think of this, if you want to think of it as, you can think of either of these two ways. The denominator is going to be the index. Okay, so again, the denominator is the index, and then we have 8, so radicand, and then I'm going to write it this way with the power on the outside. So I'm going to take the cube root of 8 first and then square it. So the cube root of 8 is, now again, if you recall, we want to find a perfect cube. So 8 is 2 times 2 times 2, which is the same thing as 2 cubed. So 3 2's inside make 1 2 outside. So the cube root of 8 is 2. And then I'm going to square that, and I get 4. Okay. Some calculators have the power button, and you can do a fraction for the power. So if you just type in 8 to the 2/3 power, you'll get the same answer. Just kind of FYI. Example 2, solve the equation including a variable raised to a rational exponent. All right, so looking at example 2 here. The technique is we're going to raise, there's a couple ways we can do this. You can do it in 2 steps, right? So you want to get rid of the denominator. So you're going to take the 4th power of both sides. Okay, and then the remember the rule of a power to a power for exponents. You're just going to multiply the powers. So 5/4 times 4, you can cancel that, and you get x to the 5th equals 32 to the 4th power. I'm not going to work that out. That's a really big number. And then now I'm going to take the 5th root of both sides. So the 5th root and we can move that 4 to the outside if we want even. That might make it a little easier. So then that'll get us x. And then the 5th root of 32, that's 2 to the 5th power is 32. So we get 2 to the 4th, which is 16. So x is 16. So our solution set would just be 16. Now, an alternate way to do it is I could have just straight, using the same idea, when I solve it, I just want x to the 1st power. So I could have done, here, let me just write it over here, x to the 5/4 power equals 32. I can just take each side and raise it to the reciprocal of that exponent, which is 4/5. And 32 to the 4/5. So here, when you multiply, you get 20 over 20, which is just 1. X to the 1, which is just x. And then the same thought process, right? We're going to take the 5th root of 32, which is 2, and then raise it to the 4th power, and you get 16. So it's the same answer, a little bit quicker. You could do it either way, whichever you prefer. All right, let's go on to the next problem. All right, actually it is our next learning objective, solve equations using factoring. Okay, so on this example 3 here, we want to solve 3x to the 3/4 equals x to the 1/2. And we're going to use the factoring technique. So you remember the zero product property that says if you have something factored equal to 0, then one of the two factors have to be equal to 0. So if we can write this, get it equal to 0, so we're going to subtract x to the 1/2 to get it equal to 0 for the if part here. Then we got to factor it. So let's see. You can factor out they both have an x, and you take the lowest power of x. So that'll be x to the 1/2. And when you divide out x to the 1/2 using exponent rules, you're subtracting. So this would be 3x. 1/2, same thing as 2/4. So 3/4 minus 2/4 is 1/4. And then x to the 1/2 divided by x 1/2 is x to the 0, which is just 1. Okay, so now we have it factored equal to 0. So we're going to use the zero product property, and we're going to set each factor equal to 0. So x to the 1/2 equals 0, or 3x to the 1/4 minus 1 equals 0. So we have two cases. So for the first factor being equal to 0, you're just going to square both sides. And then you get x equals 0. Now for this one, you got to get the x to the 4th all by itself. So we're going to add 1 to both sides. So you add 1, add 1. Then you're going to divide by 3. And then now we're going to raise both sides to the 4th power. So x equals, and then when you raise a fraction power, you raise the numerator to that power and the denominator to the same power. So it's 1 to the 4th, which is 1, and 3 to the 4th, which is 81. So our two solutions are 0 and 1 over 81. Polynomial equations. So a polynomial of degree n is an expression of the type a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 plus a sub 2 x to the second plus a sub 1 x plus a sub 0. So this is what we call descending order. N is a positive integer, and then the coefficients a sub n dot 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 to a sub 0 are real numbers. Again, we call those coefficients. And a sub n cannot be 0, but any of the other ones can be 0. Now, setting this polynomial equal to 0 gives a polynomial equation. So you just put equals 0 after. So if we put equals 0, then now it's a polynomial equation. The total number of solutions, real and complex, to a polynomial equation is equal to the highest exponent n. So if this had degree n, so let's say it's 5, it's going to have 5 solutions for the equation equal to 0. Now the one thing that they left out, it's going to have the total number of solutions counting repeated solutions. So before, like you'll see when we do this one, this has example 4 will have 4 solutions, but there may be repeated solutions. So you make it like 1, 2, twice, right? So that would count as 2 solutions, even though it's just one unique solution. All right, so let's look at example 4 here. We want to solve it by factoring. So just like the previous example, we want to get it equal to 0. So minus 80x squared from both sides. And we get 5x squared minus 80x squared equals 0. 5 divides out of both of those numbers. They both have an x, so you take the smaller power for what's in common, and then divide out 5x squared from both terms. So 5 divided by 5 is 1. X fourth divided by x squared leaves you x squared. Now we do the next term. Negative 80 divided by 5 is negative 16 or minus 16. And then the x squares cancel. Okay, so now on the this factor, x squared minus 16, you should recognize that by now. That's a difference of squares. So we square root both, x and 4, repeat it, and one will be plus and the other one will be minus. Right? And if you FOIL that, those middle terms cancel out and you get the difference of squares. Okay, so now we have it factored equal to 0. So you're going to set each of these factors. Now just to kind of emphasize this repeated solution, I'm going to factor this x squared as x times x. And then just to kind of emphasize that there's 4 solutions here. So normally I wouldn't do this. I'd just leave it as x squared. Okay, so we're going to set each factor equal to 0 so you can extend the zero product property as many factors as you want. So we got 5x equals 0, x equals 0, x plus 4 equals 0. And these are all OR statements, right? Or, x minus 4 equals 0. So we're going to get 4 solutions. X equals 0 twice. Right, so that's what I was talking about, the repeated solution. And then we're going to subtract 4. X is negative 4. And then we're going to add 4. So x is 4. So we get our solutions. So typically when we write the solution set, we don't write repeats. We just write each unique solution. So negative 4, 0, and then 4, those are all. So 0 is a repeated solution, and that gives us the total of the 4. So we got 1, 2, 3, 4 solutions, but we just have 3 unique solutions. So when you write the solution set, you just put the unique solutions. Don't write the repeats. Okay, I just want to point out the graph that the book shows a figure of here, figure 1, in the section. So that you'll notice that the x coordinates where the graph crosses the x-axis are the solutions, right? So, or solutions were negative 4, 0, and 4. So the x coordinate of the x-intercepts are actually the solutions of this equation where the y is equal to 0. So if you set y equals 0, that's the x-axis. So the solutions to this equation that we just did, instead of solving it algebraically, if I just type this into Desmos, y equals, and then I look where it is across the x-axis, those are going to be the solution to this equation. All right, so that's a good thing to know. Okay, let's look at example 5, solve a polynomial by grouping. So if you recall, right, you have 4 terms. We want to group this into 2 groups of 2. And you look at the first group of 2 terms. They both have an x, so you take the smaller power, which is square. Divide out x squared from both terms. So you could do x cubed divided by x squared is x. X squared divided by x squared is 1. Then you look at the next group and you can see, and our goal is to get this parenthesis x plus 1. So you can see that you're going to factor out a negative 9, and when you divide out negative 9, negative 9x divided by negative 9 is just x. I almost said 1. Negative 9 divided by negative 9 is positive 1. And see, now our parentheses match. This one and this one match. So we can factor that x plus 1 out, and then we're left with the x squared minus 9. Then hopefully you're paying attention and you say, oh, that's a difference of squares. So That one comes up a lot. It's pretty easy to do. You square root both. One's going to be plus, one's going to be minus. So it'll be x plus 3, x minus 3. Then we're going to set each factor equal to 0. We have three possible solutions, or we have three solutions. There's three cases for this to be true, so if any one of these factors equals 0, then it's a true statement, which will be a solution. So x equals -1, x equals -3. So with a little practice, you can skip showing this work, right? You just remember you're going to cancel that, so you got to change the sign. So if I want to cancel -3, I got to do +3. All right, and my three solutions are -3, -1, and 3. And again, if I were to type this y equals to this polynomial in Desmos, you would see it crosses the x-axis at these x coordinates. Okay? So I encourage you to try that just to see what I'm talking about. All right, on to the next learning objective, solve radical equations. Radical equations are equations that contain variables in the radicand. So that's the expression under the radical symbol. Okay, so here's some examples. So if I have the square root of 3x plus 18 equals x, and notice I have x inside the radical sign, or under the radical sign. So that would be a radical equation. The next example, same thing. We got square root of x plus 3. The x plus 3 is under the radical sign. That's called the radicand. And x is in the radicand, so that would be a radical equation. Now if you had an equation, if it had a radical like this, that's not considered a radical equation, even though you have this radical sign, because there's no variable inside in the radicand. See, that's the key. Okay, now the technique to solve these is you're going to isolate the radical expression on one side of the equal sign. So like the first example, well, the first two examples here, you have the radical all by itself on one side, and then everything else has to be on the other side. Okay? Then, if it's a square root, so these are all square roots, you're going to square both sides. If it's a cube root, you're going to cube both sides. Okay? You're going to raise it to the third power. So if it's a fourth root, you're going to take both sides to the fourth power. If it's a fifth root, fifth power. So whatever the root is, so the nth root, raise both sides to the nth power. And that'll get rid of the radical symbol. Okay? Solve the remaining. So once you do that, you're going to end up with an equation, and you're going to solve it. Now, if the equation has a radical term in it still, you have to repeat step 1 and 2. So you have to do it again. Those problems are a little bit of a pain, but they're pretty common. So like this bottom example, you would get one of the radicals by itself. You square both sides. You'll get rid of one of the radicals, but there'll still be one left over, so you'd have to repeat step 1 and 2 again. And then you have to check that you don't have any extraneous solutions. So when you're squaring both sides, you're creating, you're going to find possible solutions, so you got to verify that it's a solution to the original equation. Okay, we'll talk more about that when we do the examples. All right, example 6, solve an equation with one radical. So again, our first steps, we want to get one radical term all by itself on one side and everything else another. Okay, that's done for us. Step 2, we're going to raise both sides to the power of whatever the root is. So it's a square root, so we're going to square both sides. So 15 minus 2x squared, x squared. So the square and square root cancel each other. So those cancel each other. You just get the 15 minus 2x. Okay, now we're going to solve the remaining equation. I like to say the resulting equation. Okay, so notice this is a quadratic equation. And we just practiced that in the last couple of sections. So we want to get this equal to 0. So let's, I like to have this x squared positive, so I'm going to subtract 15 and add 2x, add 2x. I think I mentioned in the shortcut, if you want to move something, if you have an equation and you want to move it to the other side, the net result is going to be, it's just going to change the sign. So this would be negative 15 on the right side, and this would be positive 2x on the right side. Okay, so I don't have to show that work. I can just move it, change the sign. All right, forgot my square. Now it's a quadratic equation, so I have two options. I can use quadratic formula, or I can factor it if it factors. So quick check on factoring. Factors of 15, this subtract to 2. So 15, we got 1 and 15. 2 doesn't work. 3 and 5, and that subtracts to 2, so that's the one I want. Put in my signs. I want to get positive 2 for the sum, so the bigger of the two factors gets positive. And to get negative 15, these two signs have to be opposites of each other, so this would be minus. Okay, so each factor is equal to 0. Now I'm going to set each factor equal to 0. I'm sorry. So I got it factored equal to 0. So by the zero product property, I'm going to say each factor, I'm going to set each factor individually equal to 0 and then solve that. So I'm going to add 3. Again, I could just move it, change the sign. So if I move it, change the sign, that'll be negative 5. Now, these are solutions to this equation, but we have a little problem. When you square both sides, you lose some information about positive and negative numbers if you were to go back. So these answers here might or might not be a solution to the original problem. So we got to check it. Okay, so we're going to check, because these are right now, these are solutions to the quadratic equation, this one here, but they might not be solutions to the original one. Okay, so but they're the only possible solutions to the original problem. So we got to check them individually. So check x equals 3. Does the square root of 15 minus 2 times 3, I like to put a question mark above my equal when I'm checking, does that equal 3? So 15 minus 6 is 9. Square root of 9 equals 3. Check. Now I'm going to check x equals negative 5. 15 minus 2 times negative 5, does that equal negative 5? So you got square root of 15 plus 10 is 25. Square root of 25 is 5, which is not equal to negative 5. Oops, negative 5. Let me try that again. Okay, so it's not equal to negative 5. So no, this one has to get thrown out. This is what we call extraneous. Extraneous. Okay, so the only solution to the original problem is just 3. All right, number 7, solving a radical equation that has 2 radicals, containing 2 radicals. So again, our first step is we want to get one of the radicals all by itself. So let's move the square root of x minus 2. So we're going to subtract that from both sides. And again, the shortcut, you just move it, change the sign. I need to start doing that, but I know a lot of my students, they hate when I skip steps. So, but if you're comfortable with that, do it. Just move it, change the sign. So it's 4 minus square root of x minus 2. Now we got the one radical all by itself. We're going to square both sides. So I'm going to square both sides. The square and square root cancel each other. We get 2x plus 3. Now, here's where you have to be good with binomial squares. So the first term squared, if you were to write it a minus b times a minus b and FOIL it, you're going to end up with a squared. You're going to get minus ab twice, so that'll be 2ab minus 2ab. And then minus b times minus b is plus b squared. So think of the 4 as the a, and then the square root thing is the b. So we're going to do 4 squared minus 2. A is the 4, b is the square root thing, and then we're going to get the square root thing squared. So when we multiply this out, we get 16. 2 times 4 is 8, square root of 2 x minus 2. And then here the square and the square root cancel, and we just get the x minus 2. All right. So now our resulting equation has a radical in it. So we got to start over step 1. We want to isolate this radical. Okay, so let's combine like terms first. Now the 16 and the minus 2 are on the same side of the equation. So that's 14. Okay, now we're going to subtract 14 because we want to get this radical by itself. We're going to subtract x. So 2x minus x is x. 3 minus 14 is minus 11. Those canceled, those canceled. And we got minus 8 square root of x minus 2. Now it's up to you. Typically, if when I have it like this, if I could divide this number into both of these terms, I would divide. But negative 8 doesn't divide in either of these numbers, so let alone both. It would need to divide into both, then I would divide it. It doesn't, so just think of this as the radical term. It's all by itself. Now I'm going to square both sides. Square both sides. And then I'm going to use that square formula again. So this would be x squared minus 2 times x times 11 is 22x. And 11 times 11 is 121. And then when you square a product like this, you have to square the negative 8, so that's 64, and square the square root. Those cancel, so we just get x minus 2, but you need to put the parentheses, right, because we got to distribute that 64. Okay, so now we have a quadratic equation, so just like the previous problem, we want to get it equal to 0. So first let's simplify. So I distribute the 64. Hopefully I did that right. Now I'm going to get everything on one side. So let's move up to here. I'm going to subtract 64x. And I'm going to add 128. Add 128. So we get x squared minus 86x 249 equals 0. Now I want factors of 249 that add to 86. So let's see if we can do that, or do we need to use... Okay, so in scratch work, 249, get out my calculator, 1 and 249. 2 doesn't work, 3, so that would be 83. And 83 plus 3 is 86, so we can stop right there. So it'll be x, we got 3, x 83 equals 0. The bigger one's going to get the middle sign, so 83 gets minus. When I multiply to get a positive, the signs have to be the same as each other. So they're both going to be negatives. All right, so now I got it factored equal to 0. We set each factor equal to 0. So then you're going to add 3. So that would be x is 3, add 83. So x equals 83. Now before we do our solution set, we have to check. So if we check x equals 3 in the original problem, we get, okay, I'm not going to show all the work. 2 times 3 is 6, plus 3 is 9. 3 minus 2 is 1. Does that equal 4? So we get 3 plus 1 equals 4. Check. Okay, so 3 works. Now let's check 83. 2 times 83 is 166, plus 3 is 169. And again, I'm just plugging it into the original problem. 2 times 83 plus 3 is 169. And then 83 minus 2 is 81. Does that equal 4? So let's see, that's 13 minus 9. That equals 4. Yes. So both of these solutions are good. So now our solution set would be 3 and 83. Oh, I was just checking again before I moved on, and I noticed I wrote this down wrong. That should be a plus. I was forcing it to work, so I wrote minus. So plus, and that does not equal. So that's an extraneous solution. So we got to throw that one out, and we only have one solution. We only have one solution, 3. So you got to be careful even when you check, right? Make sure you copied the problem down exactly the way it is. So it was 169 plus, square root of 169 plus square root of 81. And 13 plus 9 is not 4. Okay, on to the next learning objective, solving absolute value equations. Solving absolute value equations. Absolute value equations. The absolute value of x is written as, this is the absolute value of x, so the 2 straight bars with the x in the middle. It has the following properties. If x, okay, so if the number inside is greater than or equal to 0, then the absolute value of x is just x equals x, right? So you can just drop the bars. If the number inside, if x is less than 0, if it's negative, then the absolute value of x is the opposite of x. So it's important to read it as the opposite of x. So if x is negative, the opposite of x will be a positive number. So absolute value will always produce a positive number, except if it's 0, then it'll be 0. Okay? So the way you read this is, if x is negative, then the absolute value of x is the opposite of x. Now for real numbers a and b, an equation of the form absolute value of a is equal to b, with b greater than or equal to 0, will have solutions when a equals b or when a equals negative b. So that's how you set up the equation for absolute value equations. You get this compound statement, and you'll get 2 cases. If b is less than 0, then there's no solution, because when can a positive number be equal to a negative number? So that will have no solution. Now if it has the form of ax plus b, excuse me, the absolute value of ax plus b equals c has the following properties. So there's 3 cases again. If c is a negative number, it's no solution. If c is equal to 0, it's going to be the one solution. You're just going to set ax plus b equals 0 and solve that. And if it's greater than 0, you're going to have the 2 solutions. Again, you're going to set up this compound statement up here. This expression inside is going to be equal to c, or it's going to be equal to negative c. And we'll do that in a couple of examples. All right, let's look at example 8, solving absolute value equations. All right, let's look at a first. So a, we have the absolute value of 6x plus 4 equals 8. Now 8 is bigger than 0, right? It's positive. So this is going to have 2 solutions. we're going to write the compound statement 6x plus 4 equals 8, or 6x plus 4 equals negative 8. So we get the two possibilities. And then we're going to solve these separately. So again, we subtract 4. So 8 minus 4 is 4. Divide by 6. So x, and then reduce that fraction. Divide them both by 2. So you get 2/3. Okay, so that's case 1. Case 2 is the number inside could be negative 8, because the absolute value of negative 8 would equal 8. So this number inside could be equal to negative 8. So subtract 4, and that gets you to negative 12. Divide by 6. So x could be equal to negative 2. So we have two solutions, 2/3 or negative 2. All right, let's look at B. B, absolute value 3x plus 4 is equal to negative 9. Now, again, if we're thinking about this expression, once I put in a number for x, it doesn't matter what x is. When I put it in there, times it by 3, add 4, and then I take the absolute value of it, there's two possibilities. It could be 0, or it could be a positive number. So when is 0 equal to negative 9? And the answer is never. When is, now, if for any other choice x, you're going to get, this could be a positive number or a negative number, but when you take the absolute value of it, it becomes a positive number. So when's a positive number equal to negative 9? And the answer is never. So this has no solution. The solution set is empty. Okay, so the solution set is empty. Okay, let's look at C now. So your first step is you have to get the absolute value all by itself to apply the rule. So we're going to add 4 to both sides. So 3x minus 5 is equal to 10. Absolute value 3x minus 5. So now we got this expression equal to a positive number. So that's going to give us our two cases. The number inside could be 10, or the number inside the absolute value could be equal to negative 10. So then I'm going to add 5. So 3x is 15. Divide by 3. X is 5. Or, now do the other case. Add 5. So 3x is negative 5. And then divide by 3. X is negative 5/3. So our solution set has two solutions, 5 or negative 5/3. And then D, when is this equal to 0? Let's move that there. Okay, let's do D. Okay, so this is only going to have one possibility. So if it's equal to 0, only way this could be true is if the number inside is equal to 0. So you just drop the absolute value bars and solve this. So I can move the 5x to the other side, or subtract 10 from both sides, either way, and then divide by negative 5. So x is 2. So that just has one solution. Okay, and then to the last objective, solve other types of equations. Solving other types of equations. There are many other types of equations in addition to the ones we have discussed so far. We will see more of them throughout the text. Here we'll discuss equations that are in quadratic form and rational equations that result in a quadratic. Okay, so what do we mean by quadratic form? if the exponent on the middle term is 1/2 the exponent of the leading term, then we have an equation in quadratic form. We should also mention that you should have 3 terms, ax squared plus bx plus c, which we can solve as if it was quadratic. We substitute a variable for the middle term to solve equations in quadratic form. So here's the technique. You identify the exponent of the leading term and determine whether it is double the exponent on the middle term. So again, we're looking at something that has 3 terms, and then you look at the first term. If it's, say, 4th power, and the middle term is square, and then the last term is constant, that's going to have quadratic form. So if it is, substitute a variable such as u for the variable portion of the middle term. Then you're going to rewrite the equation so it takes the standard quadratic form, standard form of a quadratic, same thing. Solve using one of the usual methods, right? All the different techniques we use for basically either factoring or quadratic formula. And then replace the substitution variable with the original term because you want to solve the original question. And then solve the remaining equation. Okay, so looking at example 9, solve a 4th degree equation in quadratic form. Solve this 4th degree equation. So we don't have any techniques for 4th degree equations yet, but if it has 3 terms in it and it has what we call quadratic form, right? Quadratic form is ax squared plus bx plus c equals 0. That's standard form for a quadratic equation. This is x to the 4th, but if you notice we have 3 terms, so it kind of looks like a quadratic. And then if you notice this is x 4th and that's x squared, which is double. If you double this, x squared squared is x to the 4th. So we're going to do a u, what we call a u substitution. You're going to let u be this middle variable portion. See, and then if you square both of these, u squared would be x squared squared, which is the same thing as x to the 4th. So x to the 4th will become u squared, x squared will become u. So we have 3, we're substituting. So 3u squared minus 2u minus 1 equals 0. And then we have this quadratic form, but u instead of x. So now we're going to solve this. So you can factor this one. Factors of 3, this subtract to 2. So we're going to do our grouping method. So 3 and 1 make 2. So we got 3 and 1u. And we want negative 2. So the bigger one gets the negative. And then this has to be the opposite. We're going to do factor by grouping. We take a 3u out. U minus 1. Here nothing comes out. Just take the 1 out. The parentheses match, so we factor out the parenthesis. And we have 3u plus 1 left over. And then we're going to, now it's up to you. You can substitute back right now. So now we're going to substitute back the x squared. Or you can solve this and then substitute back. Either way. Let's see here. I'm going to, how does the book do it? Well, they just go ahead and solve it for u. So u minus 1 equals 0. So add 1, u is 1. 3u plus 1 equals 0. Subtract 1. And then divide by 3. Okay, now remember we're solving for x, so now we got to go back. We put in the x squared for u, we go this substitution, and then you square root both sides. Don't forget to do plus or minus. So x is 1 or negative 1. So that gives us 2 solutions. Now we do the same for this, substitute back. And then we're going to square root both sides. Now this is imaginary number, so we get plus or minus I, and then the square root of 1 over 3. Now we technically probably should rationalize the denominator. The book leaves it this way, so we'll go ahead and leave it this way. So our solution set has the 4 solutions, the plus or minus 1, so 1 minus 1, and then the plus or minus I square root of 1/3, and then negative I square root of 1/3. Solving an equation in quadratic form containing a binomial. So solve the quadratic equation in quadratic form. So we have x plus 2 squared plus 11 times quantity x plus 2 minus 12 equals 0. Now a lot of students will say, let's simplify this, right? So square this out, distribute the 11, and then you'll end up with a quadratic equation, and you'll get the right answer, but you're going to work a little too hard here. If you notice that, hey, this parenthesis and this parenthesis match, they're begging you to say, let's view that as one number. We'll call it u. So we're going to do that u substitution. U is the x plus 2. So this becomes u squared plus 11u minus 12. And then this is just a simple quadratic equation that factors of 12 that subtract to 11. Well, that's 12 and 1. Figure 1's positive. To get negative 12, the signs have to be opposites. Okay, and then we set each of those equal to 0. So u equals negative 12, or u equals positive 1. And then now we got to substitute back. X plus 2 is u, right? We got to substitute back. So subtract 2 more. So x is negative 14. Or x plus 2 equals 1. Subtract 2. X equals negative 1. So again, we have 2 solutions. And that's a much easier way to do that problem than trying to multiply this out, distribute that, combine like terms, and then attack it. You'll get the same answer doing it that way. It might take you 1 or 2 minutes longer. Example 11, solving a rational equation leading to a quadratic. All right, so from our earlier section, we know to get to solve a rational equation, we want to clear the fractions. So we're going to multiply by the LCD. So if you factor, that's a different squares. We have x plus 1. Well, we have x plus 1, x minus 1. And then if you factor this is x plus 1, x minus 1 as well, so I don't need anything else. So that's going to be my LCD. So when I multiply everything by the LCD, just write all this down here. Remember, you distribute it, so you're multiplying each term with that LCD. I'm going to write this factored because I'm going to cancel. So x plus 1, x minus 1, x plus 1, x minus 1. In practice, I don't write any of this. I write this on the side, and I cancel what cancels, and then I write down what's left over, 4x, x plus 1. So I can do that without writing this step. If with a little practice, hopefully you can too. So what you cancel, what's left? 4x minus 1. And here, both of these things cancel, and we're left with just minus 8. Distribute, so negative 4x squared minus 4x plus 4x minus 4 equals negative 8. And you can see this quadratic equation. So let's see, these cancel. We're going to add 8, So we get negative 4x squared plus 4 equals 0. We can factor out a negative 4. And then we get x squared minus 1, which is our difference of squares again. There's our friend, x plus 1, x minus 1. And then set each of those equal to 0. So let's see, negative 4 equals 0. Well, there's no variable here, so basically that goes away. So we set each of these factors to 0, so we get x equals negative 1 or x equals positive 1. Now, remember when we solve these, we have to check in the original solution and if we're allowed to use it, right? Because the domain in the domain for rational functions, anything that makes the bottom equal to 0, you're not allowed to use it. So if you put in 1 minus 1 is 0, so you're not allowed to use 1, so we got to throw that one out, extraneous. And if we did the negative 1, it's fine for this one, because that negative 1 minus 1 is negative 2, but negative 1 plus 1 is 0, so that one would be undefined, so you can't use that. So we did all this work to say no solution. All right, so the solution set is empty. So you don't have to write both of these, just one or the other. Okay, and that brings us to the end of that lesson. So again, remind you to do as many exercises in the end of that exercise set, or section. There's an exercise set. Do as many of the odds as you can, preferably all. And I'll see you next time.